All right, everybody, welcome to our lesson 14 group meeting.
Thanks.
Yeah, it's you have any questions?
I don't have any questions.
All right, should we just start this quiz?
Yeah, it's 14, right? Yeah, something like
Yeah.
that. Okay. Let me open up the Excel spreadsheets we need.
I'm doing the same. One was about hot dogs.
I'm excited. All right. You ready?
I am ready.
Question 3. In an ANOVA hypothesis test, we reject the null hypothesis when there's a sufficient evidence to indicate at least one mean is different from the others. True.
Yeah, because the alternative that's like the definition of the ANOVA hypothesis.
Right. Okay.
Either
Question
all the
4.
means are equal or they're not all equal.
Right. Yes.
What requirements need to be checked when performing? It has to be normally distributed, and I think the variances have to be equal, right?
Yeah, so the data is normal, and then the variances is like the biggest one can't be greater than 4 times the littlest one.
Yeah.
And those are very mathematical terms. So 2 and 3 on that one, B and C.
So I'm putting.
Good luck, Evan. Go get him.
Is he going on a date?
He is.
Proud of him.
Yeah, me too. Question. So you got 2 and 3 on 4, right?
Yep. To check if each group is normally distributed, do the following. I think that you construct a QQ plot.
What's QQ stand for? Do you remember?
I don't remember.
That's okay. That's the right answer anyway. We assume the variance in each group is the same if the following happens. Hey, I just said this. The largest variance is less than 4 times the smallest variance.
Number 2.
Yeah. Which I feel like is a pretty big range.
Mm-hmm.
Like, as long as this number is less than 4 times as big as this one, like, we're good. It's all good. Question 7.
An ANOVA hypothesis test is equivalent to conducting independent 2-sample t-tests between every pair of samples. If there are 3 samples, there are 3 pairs. 1, 2, 1, 3, 2, 3. How many pairs are there when there are 4 samples?
Is this 4 factorial?
Well, it's not 3 factorial.
No, it's not. You're right, because there's 3 samples and there's 3 pairs. Okay, so 4, you'd have 3 plus
It should be
2 plus 1, so 6. Is that wrong?
I don't know.
Because if you think about it, if you have them lined up 4 in a row, right?
Mm-hmm.
The first one pairs with all of them, so that's 3.
Mm-hmm.
And then the second one only needs to pair with the last 2. And then the third one only pairs with the last one.
So it's essentially the number of samples minus 1 factorial.
Yes. No. N minus 1 factorial, because 3 minus 1 is 2, and 2 factorial is 2. And that didn't.
I was just like adding them together, not multiplying them. That's my bad.
Yeah. I got 6.
Okay. 6 sounds good to me. The data in soccershoes.xlsx was collected to help determine how the design of all soccer shoe affects the accuracy of a kick. There are 5 types of shoes labeled A, B, C, D, E, and also just wearing socks for a total of 6 groups. Each row represents a kick from 10 meters away from a target that was hung 115 centimeters up from the ground. The column accuracy is the distance in centimeters from where the ball impacted the target to the center of the target, so smaller numbers are more accurate. Wait, is the distance from where the ball impacted the target to the... Oh, okay, that makes sense. So just how close it was from the center. Or I guess how far away it is from the center is what they represent.
I'm just putting all these into the NOVA test. What is the minimum smallest variance for the 6 groups?
I'm still copying and pasting. I feel kind of... I used to be spoiled where they were just like side by side. Now I have to go through, find B, highlight those.
I know, right?
And
All right, I have an answer for 8 when you get there.
what is the minimum variance for the 6 groups? 27.208.
Yes. Yep. Okay. What was the maximum?
53.158.
Okay. The test for equal variances is satisfied for these data points. Yes.
27 times 4 is over 100. So
Construct a QQ plot for each of the 6 samples. Each of the samples are approximately normal based on the QQ plots, true or false. Okay.
do you know of like a fast, easy way to do these QQ plots?
So the very first Excel sheet that we had
Oh,
has a QQ plot section.
yeah, it does.
And so you just copy and paste the data into that column, and then you just have to sort it.
Do you paste all of them, like A through socks?
No, you have to do them one at a time.
Okay, that's what I thought.
Uh-oh.
Not looking normal for you, is it?
No, is it looking normal for you?
Nope.
Okay, hold on a second. I'm just going to not save that. And I'm going to reopen it. I think my Excel thing kind of freaked out for a minute.
Well, I'm pasting them all in, and it is not approximating normal.
Did you sort them when you pasted them?
No.
So you have to sort them. Sort column A from lowest to highest.
Okay. So okay, you know what? That's actually looking rather normal.
Okay, just give me a second. There you go. So yeah, variable 1 is normal.
Variable 4 is normal. That's the first one that I sorted.
2 is normal-ish.
I'll do 5 if you want to do 3.
Yeah, that works. 3 is also normal.
5's looking normal.
Okay.
Variable 6 is approximately normal.
Perfect.
I'm going to call it true.
Yep.
Perform an ANOVA test in SPSS and observe that the p-value is 0.081. Then remove the SOX data and perform the test again. What is the p-value when we remove the SOX data? So wait, what's the p-value right now? It is 0.0809 or 0.081. Okay. So now we get rid of SOX. And the p-value is 0.309. Is that what you got?
Yes, sir.
The test statistic for an ANOVA hypothesis test is an F statistic. Is the p-value the area to the right or left of the F statistic?
It's to the right.
Why is that?
Because F statistics are right skewed. And so you only do the tail to the right because there isn't a tail to the left.
Okay.
I think. Pretty sure.
Are you looking at the hot dog one?
Mm-hmm.
Kind of interesting.
So it wants to know calories in the but we have to do QQ plots for all of them too.
So
I'm just posting it in the thing first. Oh, hey now.
I'm doing.
Are you doing QQ plots?
Well, not yet. I'm not.
Okay. I will start doing QQ plots then. Group 1. Group 1. Number
Okay,
1.
so I'm supposed to take both the calories and the sodium, right? Is it wanting both of them or just the
No,
calories?
right. So question 14 says, let's examine the calories first.
Oh, man. Well, let me just clear this.
Okay, while you do that, I'll get the QQ plots done. First two, ooh.
Okay.
What is that data point? There's an outlier in the second group. That
How come it doesn't give me an F statistic and a p-value for just 3 variables?
It should. Hold on a second. There's also an outlier there. Why is there an outlier?
I'm going to close this and open it back up.
There's an outlier in all 3 data sets. But they all seem fairly normal besides that. I got a F value and a P value.
What the? This is not liking the way that I put things in, I guess. I'm going to redo it. Yeah, okay, this starting to look better.
I got A for question 14.
Okay, I'll go with it. Run an ANOVA test to determine if the mean number of calories is the same for all 3 types of hot dogs. It's not.
That P is 16074 and that P is 0. With a level of significance of 0.05, what conclusion can you draw? That they're not all the same, right? Because we reject the null. Right?
Wait, but P is less than the level of significance, which means that we reject the null, right?
I think it's D. We have a sufficient evidence to claim that at least one of the hot dog types have a different mean number of calories than another type.
Okay.
Because that's all it really tells us. $16.
Now let's do the sodium levels.
Construct QQ plots. What if I don't want to?
Kind of time consuming.
Okay. So group 1 is normal. Group 2 is normal. Group 3 is normal, mostly. Is that what you're thinking? Okay, you should see that the QQ plot for poultry suggests a possible problem with the normality assumption. The smallest variance is 7180 and the largest is 10,000 something. Have the assumptions been met to use ANOVA? There is a variant, like it is not quite linear for the third one, like it kind of moves around a little bit.
Okay. But 7,000 times 4 is 28,000.
Right, so the variances are normal or like equal. So, but the two things that need to be assumed are that.
Oh, that they are equal and that it's also normal.
So does that mean it's not safe to assume each of the groups comes from a normally, but we can assume the variances are equal? So C?
Yeah, that sounds good to me.
Despite the possible problem with the QQ plot for poultry, you decided to go with the test to determine the mean sodium levels. What is the p-value?
So I got something in like super tiny.
I did not.
No?
What did you get? Something like times e to the whatever.
Negative 25, yeah.
I got 0.179.
Really?
Yeah.
Interesting.
Here, I can show you if you want real quick. Can you see my screen? Is this what you have?
Why is mine way different than yours?
Like all of your data?
A good chunk of it.
Do you have anything like down here in the lower ones that's still populated? Like you didn't delete everything?
I don't think so.
Hmm.
Nope.
I don't know.
Wait. Wait.
I'm waiting.
Alright, I copied some of the calories and put it in the sodium.
Hmm.
Let me fix that real quick. You got 0.179?
Yes.
Alright, cool. Glad that's been resolved.
I got A for 18. We keep the null. Fail to reject. Right? Yeah, something like that.
Yeah. And we're done. You want me to submit, or do you want to submit?
I submitted it. Oh, hurtful.
What happened?
19. We got the last one wrong.
18?
Yeah. What conclusion can you draw about the mean sodium levels of the three types of hot dogs? Level of significance. So we failed to reject the null. The null hypothesis is that all of them are equal, right?
Maybe it says we do not have sufficient evidence to reject the claim that all three hot dogs have the same
So
mean.
that's probably more accurate because it's like we fail to reject, right?
Yeah.
All right, hold on. Will you go through this again with me?
Yep.
Gosh dang it.
Sorry that happened.
That's my fault. I'm the one who said A. All right, true and true.
3 is also true.
And 4 is 2 and 3.
Yep. 5 is 3. 6 is 2. 7 is 6. 8 is 27.208. 9 is 53.158. 10 and 11 are both true. 12 is 0.309. Are you keeping up?
Yeah, you're good.
13 is right. 14 is the first. 15 is 4. 16 is 3.
Wait, 15 is what?
The fourth one.
Okay. 16 is
The third one.
Third one, and then the p-value is 0.179.
Yeah.
And the second one?
We're saying it's the second one. I'm going to submit it.
Yeah, I'm going to let you submit this before I do anything.
Yep, that was it. 20 out of 20.
Dang. Cool. My God, we got a test in this class this week.
Yeah, we do. That's what next meeting's about, right?
Probably test review.
Yeah. All right. Well, I'm going to stop this broadcast.
Peace out, homie.